Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Lichee Pi 4A RISC-V single board computer. So let's dive deep into it. So what is this? On top of a very good name ripoff, it's a single board computer that is specifically targeting RISC-V. Now you have to understand, right now after the success of Raspberry Pi, lot of single board computers came to the market, each offering something different. But most of them are directly focusing ARM hardware, like the SoC in them is ARM based. Some of them have x86, but these are the only two. However, people want to jump into RISC-V. Why? RISC-V is an open source architecture. The core level, the actual physical silicon gate formation, that's instruction set architecture, that puppy is open source. So for many people, that's like they want to get into this simply because if you are developing a product and you understand it to the core level, you don't have to pay licensing fee. For example, Apple has to pay a lot of licensing fee to ARM, even though they themselves are developing the final design. But because they are Control C, Control V the ARM core, they have to pay a boatload of money. So for that reason, for many companies want to jump into RISC-V. Now that creates a chicken and egg scenarios. Like, yeah, people want to develop, but they need to have final product in order to use it. So TH1520, a quad-core RISC-V CPU made by Alibaba. Now be mindful, Alibaba was a very big company, very successful company, and obviously Xi Jinping got very paranoid about it and he yeeted the company. So now the company is split into multiple small groups. One of that small group is Alibaba T-Head, that is in China right now. That puppy is actually making the silicon. Now, most likely it's being made in Taiwan, but that's what we are talking about here. And it's a development board for RISC-V SoC and for products and tool. Meaning, if you want to actually develop something, let's say a TV, whatever have you, I will talk about what many things can be done. If you want to develop a tool, you need the software development kit. You need what, when I worked in a game studio, we always get like a console. Like this console looks like more or less the same console as you will get in your home, but it's completely different. Like hardware is completely different. What we call development kit. We develop game on that kit, then we package the game in and deliver it to you. Same thing happens with SoC. Same thing happens with every mobile phone you have. Somebody had to have something like this to develop everything out, then create the final output. So you need that. Like the sole reason Raspberry Pi was successful, they figured it out to like make it good enough where it can be sold to common people, and nerd could adopt it. The moment nerd adopted it, enough of them would have sold it. That created a feedback loop where it became successful. So same thing is happening with RISC-V. Slowly, like this is a second single board computer that I'm covering. So they have three options: 4 GB at $85, 8 GB at $99, 16 GB at $145. Now, I have no idea why they have 4 GB, but apparently they did a survey or like Twitter. It's like what most people wanted: 4 GB, 8 GB, 16. Most were focused on 8 GB because I think the price is just right, $100. So this is the board, and this is the carrier board for it. This is the box. So this is Lichee Pi 4. So let's talk about its specification. Now, in terms of raw horsepower, as in like how much teraflops this puppy can do, it's powerful, like flat out. You don't need to go deeper into that. It's just like it's a powerful hardware. So TH1520, it's a 12 nanometer node. Be mindful, Raspberry Pi, to keep the cost low, they generally use a much more ancient node at 28 nanometer. So it is much more cutting edge. RISC-V cores, 2 gigahertz, and C910 series of cores. Basically, when you see about ARM cores, they will specify like which version of ARM. So this is the same thing. Which version of RISC? C910. 4 of them. Powerful puppy. On top of that, nowadays, lot of people are utilizing neural networks. Even your mobile phone has neural network to do what will software computation on photography. For that reason, you need what we call a neural processing unit. This puppy has neural processing unit. The only other device that has, like, there are some single board computers that target that niche, but the first one that made it popular was Jetson Nano from NVIDIA. So neural processing unit, meaning you can run advanced neural network code for very less energy draw. So you can run something complex for very little power. It's almost like how we have dedicated GPU for GPU task. For neural networking processing task, you need NPUs. This puppy has that. On top of that, the board, not this part, this is the core. The board part has dual gigabit Ethernet. It's like somebody sat down and is like, hey, we really should have dual gigabit Ethernet. It allows you to do so much more things. So now that has that. It has four USB 3 5 Gbps bus. Powerful puppy, and it has L low power DDR4X, that is 300 basically 3733 megahertz. That's literally only few years ago in a laptop grade. So this puppy is powerful. The only thing that is less powerful is it has only 20 pin GPIO, general purpose input and output. Now you're like, why? Well, they're not focusing on that. They're more focusing on computer. So this GPIO is just for add-on things. And if you truly need to run, let's say, a factory and all that, in those scenarios, you generally will have subordinate ICs. Those ICs will do the main bulk load. So 20 is more than enough for that. And it has eMMC by default. So you buy it and you can just start using it without even adding SD card. Many applications do not like SD cards. They want something a bit more robust, bit more oomph. eMMC has that. And you can see like they put everything with, if you buy a little bit of transformer, you can put that into PoE, power over Ethernet injector, and this puppy will absorb power over Ethernet. A lot of options. Basically, they looked into Raspberry Pi and it's like, yes, to all of it, everything. They just amped it up, and they did not did the weird thing of Raspberry Pi, where the Raspberry Pi has two display ports rather than two. Like, why does it has two basically display port? Most people are saying it must have been like because somebody has placed order for dual panels thing you see on, like, basically stores where your customer is typing on one end and the cashier is using it on the other end. So that's the reason people have come up with like why the heck it has two micro port, because again, having one large HDMI is far better than having two micro HDMI. Micro HDMIs are expensive and they break, so it makes no sense. Here they have one full size, and if you want to connect more, they have connectors. So if you want to make it into a laptop, you can just do it. So it's like basically they looked into Raspberry Pi and they just amped it up. They just amped it up, and the CPU is powerful enough where it can absorb the oomph needed for it. So what's the target for this? Well, target is it has power. Let that be very clear. I can read the spec sheet, but does not mean anything. It just has power. So you need to know the software development kit side of things. For example, this is the hardware. You have to develop something out of it. Let's say you want to build a surveillance tool for it. You have to do the polishing work. You have to refine the software. The hardware is there. You can buy it. They will give you a basic SDK to get started, but you have to go deep, and you can go really deep because ISA is open to public. So you can go really deep and refine your product to run very low latency, very high efficiency. That's up to you. So this is one thing that Apple did understood very early on. It's like, it's not the hardware nor the software. It's the marriage of those two. Basically, it's like adding 2 plus 2 and getting 22. It's emergent property. So you have a good hardware, that's awesome. You have a garbage software, it's nothing. Output is garbage. You have like awesome software, hardware is garbage, output is still garbage. You need both of them balanced and integrated well enough. When you have that, then you have butter, and that's what we want. So same thing is here. They are giving you tool, you have to make the final thing. You have to understand this is not what you call consumer product. It's not like, oh, I'm going to buy this is going to be awesome. It's not made for that. It's made for companies who have, let's say, a software development team where they're like, okay, 10 people, go. You just grind this puppy down and you make sure your software works flawlessly onto the deepest level. And let's say if it's a big company, whether you are making LG or Samsung or you're making something big, then you can be like, we figured it out, everything is awesome. Maybe you are able to spin up your own silicon because ISA is now open. So it can be done. What things can be made? Well, router is the first thing. They have a metal box which literally looks like they're asking, hey, can you please make us into router? And routers, yes, they are desirable thing, because while there are pro grade routers, those routers have so much money. It's like if you have to ask their price, you can't afford it. That kind of prices are there. Nothing in between. Like basically you have a basic bitch router and you have god tier router. Nothing in between. This sort of thing really slots well into that. Now you're like, why can't we just convert old computer? Size and power, and not to mention people do not like the idea of having a freaking computer running all the time, especially if you are just a small business. Yes, money do matter. So having something like this, there are other tools, be mindful, there are other tools, but having something where you can go really deep, that allows you to do some really deep things if you have software development team. So that's awesome. Then you have cluster computer. For this is like a very significant advancement in computer science. This hardware may look like, oh, this only has like this much. Here's the deal. You go back 10, 15 years ago, this was running the literally World Wide Web, like flat out. Right now we may look down on it, but this is more than competent enough for more than enough things. Like you can actually do things with it. People have deployed this as a final tool be it with Raspberry Pi, be it with some other version, or be it with this. So this is a useful tool, and for students, this is like sure to take money. Colleges are buying this in by boatload. Why? How else would you give them? It's like, hey, this is what happens if you try to connect, let's say 1, 2, 3, 4, 5, 6, 7, 8 computers. How do you gonna teach if you do not have 8 computers? Here's the deal. So these sort of things are like very niche case from outside, but it's a very important backbone technology. So developing this, awesome. Cluster computer, network attached storage, low cost laptops, and yes, they physically made a laptop where you just eat this module into it and it's a full-fledged laptop. Now, like, is it powerful laptop? Hell no. But here's the deal, these laptops are not even targeting consumers, they are targeting industrial users, meaning where you have a computer running, it's running some application and you need one, basically a terminal, so to say. These are glorified terminal. Or if you are a HR, where majority of your job is just like freaking reading emails and understanding those mails, more than good if you are accountant, where you're gonna just deal with a Excel sheet. Unless you are talking engineering Excel sheet, this should be able to handle it. Engineering Excel sheet becomes stupid. They require terabytes of RAM. Not joking. So low cost laptops, even tablets. So that's there. You have TVs like this. TV is from LG. What do you think is the most expensive part in the supply chain from LG's point of view? The mother glass, absolutely. But on top of that, the second most expensive thing would be the SoC that goes behind it. If let's say you are a startup, you can buy mother glass from basically LG. If you have enough bulk order, they will sell it to you. Heck, Sony buys it from them, so you can buy it. But like, how do you make it smart? Can you develop your own? Is it like this has, I think, A9 or something like that? Like, can you develop your own? Hell no. But you can buy this puppy and put it in backside. And again, many of the what we call enterprise and for signage and all that, those computers, they literally do this. They will buy the panel from whatever manufacturer is selling them, and behind that, if you open it up, it's exactly a full-fledged computer, single board computer. So for many people, it's like short up, take money. Machine vision application, that comes back to the neural network part, that it has a neural network, so you can run something like this. Or maybe you're running a factories, like pick and place machine, things of that nature. Having actual on-board neural processing network means you can do a bit more oomph, with it. Then DVR, digital video recorder, security systems, all of that, it can be done. So, and it's a really good tool for small scale developer. So do not think of them as like, oh, I'm going to buy this and I'm going to make a computer out of it. You can, but that's not the end goal of it. End goal is a bit more wide, bit more behind the scenes, so to say. So that's the target of this. Now let's understand the politics of it. Now you're like, why the heck computer matters? Well, computer is intermingled with politics. Well, because CCP and China, they did some naughty things. They did really naughty things. Basically, they did the forbidden thing of thou shall not eat the golden goose. They did that. So nowadays, every country, including India, including Japan, including Taiwan, including every Tom, Dick and Harry else other than Russia and North Korea, everybody else is like, we have to let this go. We have to let this disappear. We are just like, no, we just have to nope it. So what they are doing is sanctions. Now sanctions are slow poison. Let that be very clear. If you were like, oh, they applied sanction, nothing happened. That's not how it works. It takes time, as in like years, it takes time. So sanctions have been applied and it's working, but it's a very slow thing. Like Hawaii company was the first victim, so to say, but this has spooked Chinese industry, all of them, where they're like, no, we will have effect. No matter how quickly we try to rip it off, it's not working as efficiently as they have thought. So they're under pressure. It's a slow pressure. Let that be very clear. It's a slow thing. It's going to take time. Heck, 2024 is the starting date of TSMC plant that's going to work in USA. So it's a slow thing. It's going to take its time. But it's wiser from somebody under Xi Jinping is smart or gives a damn about the country. It's like, it's much wiser to build competence into things that cannot be taken away from you. Let's say you build competence on x86, and over time, like all the Western companies really get their shit together and they're like, okay, let's remove x86 from China. Let's remove basically ARM from China. Of course, latest and greatest, what they have already have, they will have. But latest and greatest, let's remove that. It will create a scenario where all the people who are employed, educated, trained for those architecture will be stuck. So for that reason, it's much more long term. This is not 1 year or 2 years. These are decades long plan. Much better to build competency on open source tool. Those things cannot be taken away from you, and it's much more safer. So, and this also allows them to get at least not the hardware, but the everything else they can get from very reputable source. So it's much better in long run for China to just jump into open source. Rather than trying to rip basically Microsoft, it's better to rip Linux. Now, they do not have good track records. There are many Chinese companies that have employed this tactics. For example, Creality, I do have their 3D printer. They basically took Merlin firmware. Now be mindful, 3D printers are ancient technology. They have been made as early as like 1970s. Like, it's an ancient technology. The reason why it was not common, of course, development of silicon, but because of the software, the G-code running algorithms were idiotically expensive, and not even expensive, it was not even flat out not available. Some professor got together, they started to develop rip rap, so to say, and that's how it grew. The community started to create more intelligence, community grew, the more intelligence got in, brick by brick, Merlin came to be, and Merlin is god tier powerful. If you know what you're doing, Merlin is like, bro, I got this. It's a really, really powerful tool. What Creality did is, they built the hardware, that's Control-C, Control-V, that's not hard thing. They Control-C, Control-V the firmware, and the flat out did not give, basically you have to give credit, it's like it's a Merlin firmware. They did not do that. Now be mindful, go into 3D printer channels, they will go really deep into it, like what happened, how they did it. But the reality is, they have done it, and the record is not good. Now what is not good here? Because be mindful, I'm an open source user, let's say I use some open source tool, I'm not going to contribute to it, I'm not that smart. But here's the, I'm going to say, I'm just using the tool. They are ripping the tool and claiming it their own. That's naughty, flat out not. And not to mention, they really have very bad track record of giving back. Meaning, you used Merlin, no problem, that's what's the intent of it. But please give back. Like, if you figured it out, hey, this code is not working, this is our fix. They're like, we have the fix, but we are not going to give you it. Dude, that's not how it works. You're supposed to be two-sided. So politics are taking a very big role into this RISC-V. And I think somebody smart working under him is like, hey, let's just, it sounds very cool where it's like, we're gonna rip off latest and greatest Intel. It's like, but if you really did that, like somehow successfully managed to rip off Intel, yeah, bye-bye the next generations. So for that reason, it's much wiser to say, hey, open source. And nobody even talks about it. So it's much wiser to do that. So politics is playing a very big role, and chip projects are taking a shape. Even in India, iPhones are being made in India now. So what we can expect in the future? Well, right now, RISC-V, it was a very good use, because world is kind of stuck with, there are three major ISA. One is x86, another is basically, after x86 is ARM. ARM is the most widest used, and then you have PowerPC, and there are some others, but those are very rarely used. So people wanted something that they can teach in colleges, universities, learn on it, study on it, and then work on it. Right now, what they have is like a guess protocol. And then once you guess it, then you go to the job, then you relearn everything from scratch for like at least 1 to 2 years, and then you start working on the damn thing. And because of the increasing complexity of SoCs that we are building now, it's becoming a bit more difficult. So for that reason, professors got together as usual, and they're like, hey, let's make a proper ISA. We are teaching everybody, so what if we make the ISA? RISC-V was one. Then slowly at some point they realized, hey, this can actually become a thing. How about we figure out all the paperwork, all the jazz that we need to do to make it into a physical hardware? They succeeded. So RISC-V now is a very big community, as in with some deep pocket. Like what kind of deep pocket? Samsung, Intel, Apple, Qualcomm, like some deep pockets, like very deep pocket. Heck, other countries are jumping into it. For example, India made its own basically CPU, so to say, but that CPU is running on RISC-V architecture. We can do that. Legally, we can do that simply because it's open source architecture. That's the whole point. More and more people are jumping into RISC-V. However, the most places that RISC-V is working right now, it's microcontroller level. Basically, ARM is losing the microcontroller war. Not right now, because again, if you designed my air conditioner, my stabilizer, these things have ARM controllers. They're gonna have it, because I think pretty sure they have not been retouched for 10 years. So they're going to keep working. But new devices that are coming out, they're thinking about RISC-V. And some devices, for example, your SSD controllers in Western Digital are already RISC-V. So more and more microcontroller level things are getting done by RISC-V. That's awesome. But not as a compute platform, not as a like, hey, SoC in your mobile phone or SoC in your laptop. None of that. Like, that's not happening yet. So in those scenarios, basically normal general people consumer product, x86 ARM is still the king, so to say. So RISC-V will benefit directly from this sort of hardware, because the moment hardware touches the user, more and more people comes to monetize it, and more this gets polished. So again, Raspberry Pi is a very good success story. So this should also happen with RISC-V. wider adoption because of consumer demand would be awesome. As a compute platform, let that be very clear, compute platform. It's fun in games, it's really awesome that you are, let's say, building a BLDC fan controller motors and all that. That's awesome. Building TV is awesome, but it needs to touch computer. It needs to be computer like x86 and ARM. Only then it can like truly spread out its wing. So it needs that. Now this is another board from China that is using a 64 core RISC-V system, and you can say like this is a full-fledged computer. Like who needs this? Well, more and more servers are being utilized by ARM structures. They have ARM. Now problem with that is like how the heck you develop for hardware that is in a server? You need something that is similar in architecture. That there is another brand, Ampere. They make basically ARM CPU. So it's a more closer competition is Ampere, not a x86 architecture from EPYC and ROM from AMD. None of that. It's more for people who need ARM architecture SoC crunching thing. They're gonna use this. Like this is awesome. Like more and more people are jumping into as a compute system. It's really wholesome. And ARM and x86 will have competition, and this is a long term really awesome. This will keep ARM reasonable in terms of cost. This will also keep x86 innovating. So it's a good thing that happening. We have whatever the politics may be, but it's a good thing in long run. Everybody will get something useful out of it. So this was my presentation on basically RISC-V SoC that new puppy has come into town. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.